G'day chemistry students, and welcome to the first video for module 2. Now we're beginning to enter this second module, Introduction to Quantitative Chemistry, and in this module in particular, what we're going to be focusing on is, rather than a lot of the big concepts that underpin chemistry, a lot of the things that we saw in the first module, here we're going to be looking at a lot of the techniques and skills and calculations and ways to talk about and understand chemistry at a quantitative level, a way that's measured. As scientists, we are measurers. We don't just observe things and explain phenomena by what we see, but also by what we measure. And a lot of the things that we've already talked about to begin with, we've talked about qualitatively, we've talked about them as ideas or concepts, but they've been proved by quantitative means. And so what we'll be looking at is how chemists quantify the world in this topic. Now, to do that, what we'll be doing first is looking at some gravimetric analysis techniques. Now, you may have done some of that already in the separating mixtures practicals that you would have done in module 1, but I wanted to go through an actual practical, a simple reaction, and show you some of those gravimetric techniques, because when we're in the lab, one of the ways in which we can actually measure different substances and how much they are and all that sort of stuff is by mass. So gravimetric is talking about the force of gravity, metric is talking about measurement. So measurement by gravity, in other words, we are measuring weight, and we convert weight into mass because we know that the gravity on our Earth is constant. Now, in this practical, what we're aiming to do is determine if there are any mass changes in a precipitation reaction when 50 mils of calcium nitrate is added to 50 mils of sodium carbonate. Now, the reaction over here highlights what's going to happen. We start with calcium nitrate and we start with sodium carbonate. And when those ions in solutions, because they are both aqueous, as our brackets say, when those ions come together, the calcium and the carbonate ions will form a solid, and that will be the precipitate, while the sodium and the nitrate ions will remain aqueous. Now, the idea here is this precipitation reaction. Look, it may be something that you have already seen, say, in year 10, maybe even in year 9. But this precipitation reaction is something that we'll look at in a lot more depth as a reaction itself in module 3. For now, we're using the reaction as a way or a means to measure mass. And with that, let's get to it. So first off, what we're going to be doing before I actually show you the reaction that I undertook in the lab, I want to talk about how to weigh liquids by mass. So the best way to do so is to weigh the container that you're about to put the liquid in, transfer the liquid into the container that you've just weighed, and weigh the total mass. Excuse the typo, but we're going to weigh the total mass of the container and the liquid. We're then going to calculate the mass of the liquid by taking the difference of the total mass and the mass of the container. In other words, if I had a sample of water and I wanted to measure how heavy it was, I could take the mass of the beaker, let's say it was 25 grams, the mass of the beaker and the water together was 70. Well, the difference between the two, 100 minus 25 is going to be 75 grams. Everything that's remaining is going to be the water that we have added. And this technique is really effective, mostly because say in an active lab where there aren't many balances, you can't really tear the balance and do a reaction and come back half an hour later expecting that the balance is going to be ready for you to weigh. So if you know what the mass of the container is at all times, you can always just do that conversion yourself. But anyway, let's go have a look at this reaction.
So the first step that I will be taking is transferring the calcium nitrate and sodium carbonate solutions into measuring cylinders. Now, I believe the aim in the slide said that we'd be using 50 mils of both the calcium nitrate and sodium carbonate. When I did the practical in the lab, I actually used still equal volumes, but 100 mils of each solution. Once those solutions are ready to place into beakers, I'm then going to weigh beakers 1, 2, and 3 first. Once those beakers are weighed, I will then transfer those results into my tables. You'll note that I have tables set up for beaker 1, beaker 2, and beaker 3 already set on the board. My mass measurements will go into the corresponding cells. I'm then going to transfer the calcium nitrate solution into beaker number 1, as well as the sodium carbonate solution into beaker 2. From here, I can take a measurement of beaker 1 and the calcium nitrate and record that mass into my table. Following that, I will take beaker 2 and the sodium carbonate solution and record the mass of that as well. With the data that I have, I can take away the mass of the beaker from the mass of beaker and solution. This calculation will give me just the mass of the solution itself. And finally, I'm going to combine the two solutions in beaker 3. We should notice that we form a white substance in the beaker. This is a solid precipitate that has come out from the calcium nitrate and sodium carbonate solutions. In particular, the solid that we have formed is calcium carbonate, which is insoluble in water. I then take the measurement of beaker 3 and the two solutions and record that as well. Now, when we look at our results, what we find is that the mass of the calcium nitrate solution is 103.21 grams, and the mass of the sodium carbonate solution is 102.3 grams. When we add these two values together, we find that the mass of both the solutions is 205.51 grams. This value is extremely similar to the mass measured in the beaker using our gravimetric techniques. Now, there's a couple of reasons why we may see a slight difference in the mass. The first one being that potentially not all of the solution was transferred out of beaker 1 and beaker 2 into beaker 3. Technically, there may be some degree of mass loss in this step, and it's not been accounted for in beaker 3 because it never entered the beaker. A second reason for mass loss in a reaction is that potentially we form some products that actually left the beaker. Considering that we are forming a solid and not a gas, the outcome of mass loss due to the chemical reaction itself is highly unlikely.
Thank you very much. Now, in the next video, we're going to be looking at stoichiometry and balancing chemical equations, the idea that reactions occur in whole number ratios, and that we can use that concept to actually write out equations that tell us the amount of each substance that is reacting. But until then, have a good one.